Within the trucking industry, many different configurations of trucks exist. Engines, transmissions, and axles are somewhat different in design and operation, requiring unique operating techniques. While there are many skills necessary to be a good truck driver, smooth, accurate use of a heavy truck transmission is what separates the professional from the amateur. Professional shifting takes practice and concentration. The skills you develop will stick with you as long as you drive a truck, and you'll be rewarded with fuel savings, less wear and tear on the transmission, and on you. Professional driving combined with proper shifting techniques is the key to avoiding transmission damage. And that's the key to avoiding unplanned stops along your route. Fuller transmissions will help you get more time on the road and less time in the shop. They're made tough with well-engineered components which can last the life of the truck if used properly. Dale Kubitschek put in 28 years with the Eaton Corporation and was a National Fleet Service Manager before retiring, so he knows a thing or two about transmissions. Dale, thanks for being here.
Glad to be here.
Dale is going to help demonstrate proper shifting techniques and show you some of the damage improper shifting can cause to your transmission. Dale, let's go inside and take a look.
Let's do it.
Okay, Dale, show us some damaged parts.
Sure, Jim. Let's take a look at this input shaft. This failure was more than likely caused when a driver improperly shifted the transmission, trying to force the gear out of synchronization. What can happen is a crack can develop in the shaft, which will ultimately lead to this type of failure. Another example is this main shaft. If you're looking at it, you wouldn't think there's anything wrong with it. However, if you take the sliding clutch, is what you shift with, line it up on the splines, this should slide up and down like this. However, if it gets back down here, it hangs up and won't go up or down, and this will cause a hard shifting complaint.
Now, a lot of these failures are caused by a condition called shock load. What exactly is shock load?
Well, it can happen when a driver starts out in too high of a gear, or if he gets a little bit nervous when his truck is starting to roll backwards and his clutch comes out too quickly. Or another example of it would be backing into a dock too hard, or in the winter when his wheels are spinning on ice and then all of a sudden they hit drive payment. And that can lead us into what we call drastic shock load. You take for this gear, for example, it can lead to cracking teeth or tearing the teeth out like you see here. This causes severe damage to the transmission, can ruin a drive shaft, and cause extensive damage to a rear end. They're big dollar failures, and it's probably one of the most expensive failures that's caused by improper shifting techniques.
Dale, before we start talking about how to prevent these kinds of failures, let's talk a little bit about lubrication, which is the lifeblood of the transmission.
Sure. Eaton understands the performance benefits of using full synthetic lubricant in the transmission. That's why they recommend using the Road Ranger branded full synthetic lube, because it meets their strict requirements. And it's one of the best investments you can make for long trouble-free performance.
In order to properly operate a transmission, isn't it important that we understand a little bit about the design?
Absolutely. Let's go take a look at the transmission.
Okay.
Okay, what we have here essentially with the transmission is a front box in an auxiliary section or a range section. The front box is controlled, its shifts by the gear shift lever. The auxiliary or the back box is controlled by air, and it's selected by a range control valve that's mounted on top of the shift lever. If we talk about power flow, we come over to the input shaft, and the input shaft is connected to this drive gear, and the drive gear turns these two counter shafts. And we can take and split a tremendous amount of load even though these gears are smaller, as opposed to having one larger single counter shaft. If you take the main shaft, which is not directly connected to the input shaft, power comes in from the input shaft to the engine, splits out to the counter shafts, and it comes into the main shaft gear that's turning.
Dale, when you're up in the cab and you move the shift lever, what you're controlling is the front box of the transmission.
That's correct. What we have is you got the gear shift lever that's connected to the shift fork, and the shift fork is connected down to the sliding clutch. So power comes in from the input shaft to the drive gear, turns the 2 countershaft gears, and comes back and turns the main shaft gears. But we still don't have any power flow coming out the front box of the transmission. So what ends up happening is you have got to get the speed of this gear with this sliding clutch to match. Once that happens, this sliding clutch will engage into the main shaft gear, and then you'll have power flow out the front box.
So Dale, what does the back box of the transmission do?
Well, the difference between the back box here is the sliding clutch here is different from what we had with the sliding clutch in the front box. This sliding clutch has got a synchronizer with friction material on it. When air is applied to the synchronizer, it moves forward. When it's going into a gear position, it has to match 2 different speeds. And this friction material, or this friction synchronizer, allows us to do that. So when the air is applied and this synchronizer is forced going into the gear that it wants to go into, will match those 2 speeds, and at that point in time you get power flow out the back of the transmission.
So Dale, can you show us how all this works in the truck?
Sure, let's go out and do it. What every driver needs to know is how to double clutch. And what you do with that is when you're in a gear position, you push the clutch pedal down, which releases the clutch, move the gear shift lever to neutral, release the clutch, which engages the clutch, quickly push the clutch pedal down again to release the clutch, move the gear shift lever in the next gear position, and then release the clutch pedal, which engages the clutch. And that's basically how you do a double clutch.
How do you know when to make a shift?
What you're trying to do is you want to match your engine RPMs to your road speed. And the tachometer is a valuable tool to do that with. You can use that for upshifts and for downshifts. And what you do is on an upshift, you want to decelerate the engine until you match the engine RPM with the road speed. And on a downshift, you want to accelerate the engine RPM to match the engine RPM and the road speed. The old technique was to take and run the tach up or the engine till full governed torque, and you don't need to do that. With the newer techniques, you're able to save fuel and wear and tear on the driveline. And the manufacturers of the new engines were able to lower the torque range to match those lower RPM engines. And that's what you want to do. You always want to match the engine RPM with your road speed.
Dale, I've heard of drivers who brag about being able to shift with only a single push on the clutch or without using the clutch at all. Is that okay for the transmission?
No. You can take a skillful driver or professional driver, they can make at least 80% or more of the shifts without the double clutching procedure. However, for every missed shift that they make, that progressively causes damage to the transmission. And that's where this progressive shifting is kind of a misleading term. Progressive shifting, which is basically going 1, 2, 3 consecutive shifting, has now gone the wayside, and you come into what is called professional shifting. In professional shifting, you are shifting and you're upshifting. Drivers will always try to anticipate. They want to get into the highest gear possible as soon as possible.
So professionals shift as little as possible.
That's right. What they'll do is if they have light loads or a gradual downhill decline, what they'll end up doing is they'll take and either skip shift or upshift to make use of the improved low RPM engines. And also, when a driver is going down the road and they're going to approach a hill, they'll take and accelerate and use the momentum of the truck to get up that hill as opposed to having to constantly downshift, because they want to shift as little as possible. The reason that they would also want to downshift is because if traffic dictates it, or if they fall out of the ideal RPM range of the engine, then they've got to make a downshift. They also know about the range change. They know that when they in gear position, they go ahead and they can pre-select it, and when they go through neutral, it'll make a change. They know not to shift or make a range change when they're in the neutral position, because it'll definitely cause transmission damage.
So you should be able to take progressive shifting to professional shifting if you remember that you don't have to take the RPMs to the top of the governor and you don't have to shift every gear.
That's right.
But how do you know what type of transmission the truck has?
That's a good question. One of the first things you want to do is try to look for the shift diagram for the transmission, because they have different shift sequences and they can be located in different places. They can be either on the shift lever, they could be located on the dash, or it could be over the visor.
I'm beginning to see that the driver is the big part of the system. Really the only part with the freedom to make the decisions. So the professional driver should have a clear mental image of the moving components when a lever is moved or a pedal is pushed.
Yes, the driver's going to decide when to move the shift lever, when to use the clutch pedal, when to use the accelerator. They're all inputs. He wants to get into a shift sequence or into a rhythm. And they understand this by listening to the engine, by looking at their tach. Those are all those sensory inputs that a driver gets. And the only way that you can do this is by everyday practice driving on the road.
So, in summary, Fuller transmissions use a twin countershaft design to reduce size while maintaining strength. Power flows through the main input shaft and then to the two counter shafts and then to the main shaft as the main shaft gear is engaged with the sliding clutch. Eaton transmissions have a front box, which is lever actuated, and a back box, which is air actuated. The sliding clutch in the back box has a synchronizer to allow for smooth air shifts. The sliding clutches in the front box require driver skill for smooth shifts.
Yes, there are so many different transmission models today for different trucks and different applications. And one of the things that the driver has to understand is the different shift sequences, different air systems, and how to properly shift all of these different models. And the best place to do that is to refer to the driver's manual, and then that way you will have the proper information to properly shift those transmissions.
Now we review the Fuller manual transmissions in the following 4 categories. Medium duty 5 and 6-speed transmissions. On highway 10-speed transmissions. Performance 13 and 18-speed transmissions. And vocational deep reduction transmissions. Pick the module that best matches your needs. Good luck.